I'm going to do a follow-up now to the tectonic planets video. The, the one that you saw previous to this, I did it yesterday. And I cut off the introduction because I have this rambling 2-minute segue where I'm talking about other planets. And the reason why I try to introduce it like that is to show a comparison of our planet Earth with the other planets that are in the solar system. So you've got Mercury, Venus, Mars, and also the mystery of the asteroid belt. But when you study Mercury, there are craters on Mercury and there are other features, but we don't have a lot of anything high resolution. And then the issue with Venus is that it's very active. It's very active. And there's a lot of extremes. There's many mountains and there's some kind of volcanism going on. But also the most striking thing about Venus is the atmosphere. It's a very thick, dense atmosphere with a lot of material in there and fuming gases, vapors, because it's very hot on Venus compared to the Earth. Like a humid hot. And it actually prevents us from doing much imagery in detail. Now, the Mars imagery is coming back recently because there's a probe right now, they say. If you're going to believe every information that they put out, I guess I can do that with a, just small amount of skepticism that it's even real because NASA is questionable over the moon landings, let's say. It's questionable, but I'm not saying for sure. But talking about the Mars data that's just coming in, um, the geology of the planet, I don't know if you can even use that word properly, because geo means the Earth. There's a lot of canyons. There's the features that they used to call the canals. Those are energy streams. That's like the movement of something, and it can be seen because I guess it's glowing. It's flowing energy, and it changes its position. Those canals that they talked about, or the white lines that go from pole to pole, thereabouts. They travel around. It's always shifting. Now, talking about the solid stuff that you see now, there are some craters. There are huge features, like Mount Olympus is a volcano that's like, I think it's about 25 miles high or so, or 20 miles at least. That's just off of my memory. I don't know exactly. And then there's canyons, and there's also a lot of stretching. Now, we got to talk about all the moons that they've checked out. You had Voyager take a lot of imagery decades ago. You have a lot of stuff now with other telescopes, and these moons, compared to the planets and compared to our own moon, show you a lot of surface feature and what's going on, and the crust is going through the morphing. Now, the moon even has that. If you would look, Neil Adams, who is promoting expanding Earth, he'll show you very clearly that, they do this animation. The moon's surface has darker patches, and that's where the underneath is spreading out, and it's actually causing the moon to expand, as well as that's what happens on the Earth. So you look at that, and it changes the other superficial features of the craters, because usually craters are impact of something that exploded at some time, and then it stopped, and it did this form, and then the form is going to stay that way unless it erodes. There is erosion slowly in most places that we observe. Very slow erosion that we have to assume, it's going to fall apart. In itself is a sudden change. We assume we haven't observed any craterization. There has never been any eyewitness study of the Acton process. Never. Although there was one where it hit Jupiter, so we don't really know what happened except to the surface clouds of Jupiter. But that was the only time we've ever seen it, so you got to mark that very well in your mind, that craters are all understood by conjecture or by, logical deduction. But these craters, I have a whole other theory about. I'm not going to mention that now because it would be a distraction. I wanted to talk about, well, that's a lot actually. I didn't really stick with my main point, but I went meandering around to explain the planets, how they reflect upon what must be happening on the Earth. And I could talk on that just for 5 minutes. But let's just wrap this up, because I can do another video and it'll be a whole series. I was studying the details in 3D of the ocean bottom, the ocean's bottoms, and it's very fascinating. You take a look around the world, just spin the globe, and you see everything that's there. It's just like, whoa, like it's amazing to see that shape and then understand what's going on with the crust moving on top of the oceanic plates. That's one thing, just mind-boggling in itself, no matter how long I've known about it. I don't believe in all the tectonic theory, but a lot of basic principles in there are very amazing and are pretty much true to my belief, in my opinion. Okay, so canyons, I found out that there was really deep canyon, two of them off of Alaska, and many of the major rivers have them. And I think all of them have them, except it just could be covered with sediment and silt. And that's just a rough survey that I've been doing around the edges of the ocean basins as I was studying all the features underneath, and then coming up to the continental shelf and looking, navigating in through these and seeing footage of expeditions that they've done with submarine vessels with all kinds of documentation. They find it's very rich with life in these canyons. So that's pretty obvious, because of all the stuff that's been put down there, all the broken up organic material that's still in there, just saturated into that bottom of the canyon. So of course, it's going to create an entire environment and a basis for all kinds of life to live under the ocean. Well, that's just touching on. My next video will be more details about that, and then if you have any discussion you want to have about the other planets and the other moons in our solar system, then definitely leave them here.